Bismillahirrahmanirrahim. Dear students, this is RL circuit, a physical problem, or you can say an application of the linear differential equation. How can we solve a linear differential equation problem? So there is an RL circuit which shows the resistance as well as the inductance. Now, using the Kirchhoff's law, the voltage drop across resistance is basically Ri, and the voltage drop across inductance is L di by dt. And the voltage, this is the voltage E. You can say the EMF, you can say the electromotive force, that is E. You can say the battery is E. This is the positive node, and this one is the negative node, and the current I is flowing like that. Now the question is, about application of linear differential equation. This is covering ClO3 and PlO12. A resistor of R is equal to 10 ohm and inductor L is equal to 2 henries, and a battery E is equal to 60 volts are connected in a series given by Ri plus L di by dt is equal to E. At t is equal to 0, the switch is closed and current I is 0. That is the initial condition. Analyze the current I for t greater than 0. The governing equation is Ri plus L di by dt is equal to E. Already given that, you need to find the value of resistance, and you need to find the value of you need to put the value of resistance and then inductor, which is 2, and the battery 60 volts. So substituting these values, you get 10I plus 2 di by dt is equal to 60. Write this in this way: 2 di by dt plus 10I is equal to 60. Write in the standard form of linear differential equation. So di by dt plus 5I is equal to 30. Now here I is the current and t is the time. So this is a linear differential equation in the current I. Here the dependent variable is I and independent variable is time t. The second step is that you need to find the integrating factor. Integrating factor is e raised to power integral 5 dt, which is e raised to power 5t. Multiply the integrating factor to the standard form. You get the left hand side is always be equal to d by dt of integrating factor times the dependent variable, which is I, and the right side is the 30 times integrating factor. 30 is the, you can say, q of x, and 5 is p of x. The standard form is di by dt plus pi is equal to q, where p is 5 and q is 30. So I'm writing like that: 30 times integrating factors. So simple integrating, we get I times integrating factor is equal to integral 30 e raised to power 5t dt. Finding the integration of exponential 5t, you can write e raised to power 5t divided by 5, and simplifying to get I e raised to power 5t is equal to 6 e raised to power 5t plus c. Now we need to find the value of the arbitrary constant c. Here we substitute the initial condition. Initially the current I is 0 because the switch is closed. So I is 0 when t is 0. From this, when we substitute it in 1, we get c is equal to minus 6. This is the value of the arbitrary constants. Now I is equal to e raised to power 5t equal to 6 e raised to power 5t minus 6. And from this we get the value of the current I, which is 6 times 1 minus e raised to power minus 5t for t greater than 0. Thank you very much.